Okay, exams certainly are stressful situations. Let's go through it. I'll put your last name down. My last name is Bannon. Whoops. Get my eraser out. Bannon. First name is Ron. And my phone number is 973-877-1886. All right? Honor code, basically honor code is just something about that you're taking an exam and it's your exam. It's no one else's exam. That it's your work on the exam. All right? I'm going to sign it. And then what I'm going to do is start taking the exam. So number one, find the domain of the function. Well, it's an even root, so I know the radicand, which is x squared minus x, has to be greater than or equal to 0. I'm going to factor that. That's going to be x. Then you get x minus 1 greater than or equal to 0. Now looking at that, I'm going to use a number line, and on the number line I'm going to list the zeros of that polynomial. There's two zeros. One is at 0, and the other one is at 1. All right, relatively simple numbers. What do you do now? Take test points. After 1, I pick 2. And if you try 2 in that polynomial, you'd get a positive times a positive, which of course is greater than 0, so I shade that in. All right, the next thing I do is I try 1. If I plug 1 in, I get 0, and that's certainly equal to 0. And without any sense of bias, I'll take a number between 0 and 1, like a half, and plug it in. And what do you get? You get a positive times a negative, which is a negative number. I would not shade that in. Going to go to 0. 0 gets shaded in because 0 times any number is 0, and that's certainly equal to 0. If you go below 0, like take minus 1, plug it in, you get a negative times a negative, which is a positive, which is certainly greater than 0. So what's the domain of this thing over here in interval notation? It's going to be minus infinity up to 0, including it. Union starts up at 1, including it, and goes off to infinity. Right, so this would be an interval notation, and that's the domain of the problem over here. Let's do the next one, which is analyze for symmetry. If we're going to analyze this thing for symmetry, there's 3 types of symmetry I look for. The first one would be even. How do you do even symmetry? Well, oh, by the way, it's also called y-axis symmetry. Whatever makes sense to you. So what do you do over here? You replace x by minus x and see what happens. Let's see what we do over here. 2y squared, 3 minus x cubed. Let's simplify it. You get 2y squared equals minus 3x cubed. Now, are they the same thing? No, so it's not even. It's not even. Let me do the next thing, which is odd, or what some people refer to as origin symmetry. It's point symmetry. What do you do there? Replace y by minus y and x by minus x and see what happens. And what do you get? You get 2y squared equals minus 3x cubed. Clearly not the same thing, so it's not odd. What's the last one? It's x-axis symmetry. What do you do there? Replace y by minus y and see what happens. What do you get there? 2y squared equals 3x cubed. That's the same thing, by the way. So therefore, it is x-axis symmetry. I'll put a circle in it or a box on it saying I'm done with that question. All right, number 3, it's a rational inequality. It says graph it on a number line and also express it as an interval. All right, so we're going to put this over here. It's get solve for 0 first, so x plus 2 over x plus 3 minus 4. Well, I need to get a common denominator, so I'll say x plus 3 over x plus 3, and that's going to be less than or equal to 4. Okay, got the common denominator, which is x plus, whoops, I'm sorry, I made a mistake there. I subtracted 4 from both sides, all right? So that's 0. You get x plus 3 in the bottom. And what do you get for the numerator? Well, you get x plus 2 minus 4 times x plus 3. Well, that's going to be x minus 4x, which is minus 3x. All right, then you get 2 minus 12, which is minus 10. 2 minus 12 is minus 10. Now, granted, what do? Number line goes down. On the number line, I list all the zeros. And what are the zeros going to be? Well, one is at minus 3. That's the easy one. That's in the bottom. All right? Where's the other one? Let me write that down for you. It's when minus 3x minus 10 equals 0. And that means minus 3x is equal to 10, or x is equal to, well, that's going to be what? That's going to be minus 10 thirds. Now, granted, I realize for some people looking at it, I wonder where that number is. you should realize that as a mixed number, that's minus 3 and 1/3. All right? Where does that number belong? I'm going to say over here somewhere. I'm just going to list it as minus 10/3. I'm going to take a test point, and someone says, what test point are you going to choose? I'm going to pick 0. Again, I want to claim where this test point's being used right over here. And if you tried 0, what do you get? Well, on top you get a negative number. On bottom you get a positive number. Overall, you get a negative number. So what I'm going to say is this thing shades in now because it's a negative number, and negative numbers are less than 0. All right, so I got this covered. I'm going to plug in the minus 3, but unfortunately I can't. If I plug in the minus 3, this would be a division by 0, so do not shade that in. Now I want to go between minus 10/3 and minus 3, and I'm going to say a good test point, which I know is difficult, is, again, minus 3 and 1/3 is minus 3.3 approximately. So I'm going to say minus 3.1, all right, as a test number. And what would you get over there? On top, you'd get a negative number. And on bottom, if you did that, what would you get? Well, minus 3.1 plus 3 would be a negative number. And a negative divided by negative is a positive. Positive numbers are not less than 0, so I would not shade that in. Let's go below minus 10/3, and I'm going to pick minus 10. If you pick minus 10, what do you get on top? You get a positive number, and on bottom you get a negative number. Positive divided by negative is a negative number. Negative numbers are certainly less than 0. I'll shade that in now. By the way, I forgot to do the minus 10/3. Minus 10/3, if you plug it in on top, it would produce a 0, and 0 divided by any non-zero number is, of course, equal to 0. So let's get shaded in. Let's write our answer down in intervals. It's going to be minus infinity up to minus 10/3. That is inclusive. Union, it starts at minus 3. It's exclusive, though. You can't use that number, and it goes off to infinity. All right, that's number 3. And now let's go to number 4. Okay, this is number 4. And again, I'm looking at number 4. It says, express the solution in 2 ways as a graph, a number line. It's a quadratic inequality, so let's put this over here, or polynomial. Get the 0. I'm going to factor it. Relatively simple, integer number problems. I'll check it for you, though. And that's a 3, by the way. That gives you 6x squared. You get minus 4 minus 9, which is minus 13. You get plus 6. What goes in a number line? The zeros. What are the zeros going to be? Well, let's take a look at it. And I got to be careful here. So 3x minus 2, that's one of the factors. That becomes 0 at 2/3. Put this over here. I hope you realize that 2/3 is a proper fraction. The other one, though, 2x minus 3 becomes 0 when x is 3/2. Well, 3/2 is bigger than 1, so put this over here. All right, so what do you do now? You're going to test the intervals out without any sense of bias. So a good number above 3/2, I would say pick 10. If you plug in 10, what do you get? A positive times a positive, which of course is a positive. I'll shade that in. You're going to try 3/2 out. 3/2 gives you a 0. That gets shaded in. Now I want to point out this is a number 1.5, and this number over here is like 0.6 repeated. What's a good number between those? 1. Let me get my eraser out because I really don't need to see those decimals, but I do know 1's in between that. What do you plug it in? Well, the first factor would be negative. The second factor would be positive. Negative times positive is a negative. That is certainly not greater than 0. If you plug in 2/3, though, you do get 0. That equals 0. Now, if you go below 2/3, I guess a good test point there would be 0. Plug in the 0, what do you get? A negative times a negative, which is a positive, and positive numbers are greater than 0. So I got my graph. My interval looks like this, minus infinity. It goes up to 2/3. And what do you get there? Well, it includes, including that, union starts up at 3/2, and it goes off to infinity, all right? This is the intervals, and this, of course, is the graph right there. All right, let's do the next one, number 5, a rectangle with a length L and a width W. I'm going to draw a picture of that. I'll put the W down, and I'll put the L down over here. That's my L. So it says a rectangle with length L and width W has a diagonal of 10. And that's inches, by the way. All right? Express the perimeter. Well, I know what perimeter is. Perimeter is twice L plus twice W. All right? So this is around the object. But they want me to express it as a function of L. So P must be written down as a function of L. Well, I already have part of it done, 2L. But now I could get W in terms of L. And what's that going to be? Well, it really relates back to the distance formula or the Pythagorean theorem. So really L squared plus W squared is equal to the diagonal squared, which is 100. So what do you get over here? W squared is 100 minus L squared. Kind of ran out of room, by the way. Write it over here. W is actually the root. And why is that? It's not plus or minus because W is a physical distance, or it's 100 minus L squared. So this is multiple choice. We're not really looking at your work, but we are looking at your choice, by the way. Now I'm looking for that choice over here. What am I looking for? I'm looking for PL equals 2L plus 2 times, well, I see it right now. Where do I see it? Right over here, right? That the perimeter as a function of the length is twice the length plus 2 times the root of the quantity 100 minus L squared. Well, the next one is an absolute value inequality. I'm going to rewrite it, and I'm going to take 3 from both sides, and I'm going to add that absolute value to both sides. So remember, when we do absolute value inequalities, we try to get the absolute value isolated on one side, compare with a positive number, and we have that accomplished. What do we know about this over here? That this thing is the distance from 0, and what does it say? It has to be greater than 2 units, which means that this thing could be below minus 2, or this thing here could be above 2. I got to solve both of those. Put this down, x over 3. Take away 6 from both sides, you get minus 8. Multiply both sides by 3, you get minus 24. This is all connected by an or, which is a union. This over here is x over 3. Take 6 from both sides, you get minus 4. Multiply both sides by 3, you get this over here. What do you have now? I'm going to put the number line down. The number line, 2 numbers, minus 24 is 1. The other number is going to be minus 12. What does it say? X is below minus 24. I'll put this over here. And the other one says, or x is above minus 12. So I can put my intervals down, minus infinity, up to minus 24, not inclusive, union, minus 12, off to infinity. Put a little circle on that, indicate I'm done. Let's go to the next one, and let's take a look at that. This is number 7. Number 7 is a difference quotient. They tell me what the difference quotient they want. So let's write this over here. It's going to be f of x plus h, so it's 3x plus h squared plus 2 times x plus h minus 1. Let me tell you what I just did over there. I just put that down. Now what do you got to do? You have to subtract f of x. What's f of x? 3x squared plus 2x minus 1. And that's all over h. What do you do now? Simplify it. You get h in the bottom. What do you get on top? No, it's a multiplication problem. You get 3x squared plus, well, x plus h squared is x squared plus 2xh, and 3 times 2xh is 6xh. Then you get h squared times 3, which is 3h squared. Then what do you get? Plus 2x plus 2h minus 1. What did I do there? I simplified this. Let's do the next thing up, which is subtracting away this thing over here. And what's that going to give you? Minus 3x squared minus 2x plus 1. All right, got some work to do. And the work is just kind of looking around for things like terms. So one thing I notice is that, this guy here and this guy here just cancels off, because 3x squared minus 3x squared, there's no x squareds. Minus 2x plus 2x, they disappear. And the 1 and the minus 1 also disappears. So I'm left with a simpler statement, and that's going to be 6xh plus 3h squared plus 2h. Divide by h. And you can divide by h because h is not equal to 0. Where does that say that? Right over here. So if h is not equal to 0, you can freely divide by it. And what do you get over here? 6x plus 3h plus 2. And that gets boxed. That's a difference quotient. All right, so let's keep going forward. And what number are we on now? I think we're on number 8 now. And number 8, again, some people say, oh, this is a really tough question, but not really. The domain looks pretty simple to me. I see a root problem over there. And what do I know about this? The x has to be greater than or equal to 0. Unfortunately, it's a divisor, so the x has to be greater than 0. The other restriction I have is I can't let that second factor be 0, so x cannot be equal to 1. So if I were to put that down, I would start at 0. I would go up to 1. Right? It's going to be greater than that. It can't be 1. So I'm looking for a domain that starts at 0, goes up to 1, and then it's union 1 off to infinity. And I want to point out where I see those two. Right? I actually see 2 of them that have that. I have this one here, and I have this one over here. Whoops, sorry about that. So I actually have two possibilities. The other ones are not possible at this point, all right? So what I'm going to say over here, when I say the other ones, none of the above is a possibility, but it seems unlikely. So I'm going to say, I wonder which one it is. Well, looking at this thing over here, I do know it's positive. So there's a difference between these two over here. And the question is, which one is right? I'll tell you what, it can't be 0. In other words, it couldn't include the 0. And why is that? This is a fraction, and this fraction could never be equal to 0 because the top is always 1. So A is the only possible answer over here. A. Thank you. Let's go to the next one. Number 9, I see the picture, and I see the function. And let's write this down for you. I'll write f of x for you. I'll get to the questions in a moment. I'd factor it. What do you get over there? Well, it looks like x squared minus 4, x squared minus 1. And you can continue to factor that, by the way. That's x plus 2, x minus 2, x plus 1, x minus 1. All right? So let's see if we can get the questions going. And, the first question is it even, odd, or neither? Well, I'm looking at the picture, by the way, and I'm convinced, looking at the picture, that it's an even function. So I'm going to put down even. And again, that's by inspection, by the way. If you want, you can show it's even by taking f of x and showing that it's the same thing as f of minus x. And it is. You can just look at that and see that, because what do you got? You got 4th degree, 2nd degree, and when you minus x is going to produce the same exact function, by the way. Right, domain, that's easy. It's there's no roots, no even roots, and there's no divisions, so it's all the real numbers. I'll put this over here, and that's an interval notation. Right, let's do the range. Range is a little more difficult, but I am looking at a picture, and I want to point out, in reading it, they tell me these points that they're indicating occur here. So what I want to do is I want to go through that with you. So this point over here is minus root 5 over 2. And what I want to do is I want to talk about the evaluation of the function at those values. By the way, this point over here is root 5 over 2. And what's nice about the function, I could plug it in minus or a plus root 5 over 2. And why can I do that? Well, it's 4th degree. I'm getting an even function. I'm expecting the same result. What do you get when you 4th power that? That's 25 quarters. Minus. Well, 5 times that thing squared is going to be 25 halves. Then what do you get? You get plus 4. When you go through the arithmetic, there's a common number of 4. You get 25 minus 50, and 4 times 4 is 16. What does that give you? Well, let's see, minus 25 plus 16, which is minus 9 quarters. All right, minus 9 quarters. Now, by the way, if you trace over, minus 9 quarters is minus 2 1/4. So it looks about right, minus 9 quarters. Now, someone says, why'd you do that? To get the range. What's the range going to be? Well, it's going to start at minus 9 quarters. That's the lowest point it could be. It actually touches that value. There's a point there, and it goes off to infinity. That's done. All right? The intervals where f is increasing. Let me point out what that means. As you're moving left to right, the function's going up. Well, it's going up there, and it's going up here. And this goes on forever, by the way. So let's write that down. And again, we're only moving left to right. And what's that going to be? Well, you're looking at the number. It's going to be from the root of, I'll put this over here, up to 0, union, well, the root of, off to infinity. And that's where it's increasing. All right? Next up, where's it decreasing? Well, again, I want to point out it's decreasing as you move left to right over here. This is decreasing, and it's decreasing over here. Right, I need to put that down. And again, the understanding is these graphs go on forever. Right? Domain, it says that anyway. So minus infinity up to the root of minus 5 over 2, union 0 up to the root 5 over 2. And again, we have that from the picture. All right, put a box in that as well. What's the y-intercept? Well, looking at it, I think it's pretty obvious that it's 4, but you could also look back at the function and realize it's 4. That's going to be in point form. What does that mean? X is 0, y is 4. What's the next one going to be? The x-intercept. Well, you know what? I'm glad I did the factorizations, and I'll tell you why. If I'm looking at these things, I'm pretty much convinced the x-intercepts are going to be really simple numbers. Where they're going to be minus 2, 2, minus 1. I'm sorry, minus 1 and 1. I'm going to put them down for you now, and they're going to be in point form. So I'll say minus 2, comma 0, minus 1, comma 0, 1, comma 0, and the last one's going to be 2, comma 0. And there's 4 of them. I do see that in the picture, by the way. What's the relative maximum point? Let's go back to the picture. This point over here is the relative maximum. It's relative. And what's that point going to be? It's 0, 4. All right, relative minimum point, let's look at it. I got them right over here, and I'll write those down there for you. So one of them is going to be at minus root 5 over 2, comma, minus 9/4. The other point is going to be the root 5 over 2, 9/4. And there's 2 of them, and we see that right over here. And we're done. Thank you.